Hello guys, welcome to PVS the TUTOR. Today I've got a question under physics that is under waves. The question says figure 6.1 shows a vibrating turning form supposed to be fork. Why? In air. Now it's vibrating. We've seen that something is vibrating. So whenever something is vibrating, we know that sound is produced. And sound is an example of a longitudinal wave. So the production of sound from a turning fork releases a longitudinal wave, and this wave has got what to call compression and rarefaction. So now they are stating. A says, state the nature of the wave produced by the turning fork. So the nature of the wave produced by the turning fork is a longitudinal wave. So that's the nature of the wave produced. It's a longitudinal wave, nothing else. Something that is vibrating produces sound. Sound is an example of a longitudinal wave. So that's a longitudinal wave. So the answer is a longitudinal wave. B says, show diagrammatically the regions created by the wave produced as it passes through air. Now we know that when it's passing through air, it has got particles, and these particles sometimes are compressed, sometimes are separated from each other. So it's going to form what compressions and rarefactions. So the diagram will be in this form, then separations, then compressions, then rarefactions. So these are what to call compressions, then these are what to call rarefactions, compressions, rarefaction, and the wave is going in that direction. So this is what we are supposed to show here. That's so. Compressions, rarefaction, compressions, rarefactions. C says, explain what happens to the speed of the wave in air if the rate of vibration of Y increases but the length of the wave produced remains the same. Now we know that the speed is equal to frequency times wavelength. So they are saying what happens to speed when frequency increases but wavelength remains the same. That's what they're trying to say, because the rate of vibration, that's frequency, and the length of the wave is wavelength. So what we know that the speed is directly proportional to frequency. Increasing frequency will also increase the speed. So we are saying speed increases as well, because frequency is directly proportional to speed. So when they say it's directly proportional to speed, increasing frequency also increase what? Speed. Decreasing frequency also decrease speed, as long as wavelength remains the same. So speed is equal to frequency times wavelength. These two, they are direct proportions, you can see. So increasing frequency will increase speed, decreasing frequency will decrease the speed, and vice, just like that, and vice versa. So thanks so much. Don't forget to subscribe. PVS the TUTOR.